The National Electrical Code permits ground fault circuit, interrupter protected circuits and regular circuits to be installed within the same conduit or electrical box. This allowance is governed by several key articles within the NEC. NEC Article 210.8a addresses the installation of conductors from different systems, circuits, and voltage classes within the same raceway, cable, or enclosure. It specifically states that such installations are permissible provided that all conductors are insulated for the maximum voltage present within that raceway, cable, or enclosure. This provision ensures that the insulation of the conductors is sufficient to withstand the highest potential difference between any two conductors in the installation, thereby preventing insulation breakdown and potential short circuits or ground faults. NEC Article 210.8b focuses on conductors of multiple circuits supplied from the same transformer. According to this article, conductors, including grounding and bonding conductors of two or more circuits that originate from the same transformer, are allowed to occupy the same raceway, cable, or enclosure. This permission is granted without regard to whether these circuits are functionally associated with each other. The underlying principle here is that circuits derived from the same source transformer share a common voltage reference, which minimizes the risk of voltage differences causing insulation stress or other electrical issues. NEC Article 406.3d introduces a critical restriction concerning ground fault circuit interrupter protected circuits and their connection to separately derived systems. This article explicitly states that ground fault circuit interrupter protected circuits must not be connected to any circuit that is part of a separately derived system. A separately derived system is an electrical power source such as a generator, transformer, or solar inverter that is electrically isolated from the main electrical service. This isolation results in the separately derived system having its own neutral point and grounding system. Connecting a ground fault circuit interrupter protected circuit to a separately derived system can cause the ground fault circuit interrupter to malfunction or nuisance trip due to differences in the grounding references between the two systems. Considering these NEC articles in conjunction, the key takeaway is that ground fault circuit interrupter protected circuits and regular circuits can indeed share the same conduit or box, provided certain conditions are met. Firstly, all the circuits must be supplied from the same transformer. This ensures that they share a common electrical source and grounding reference. Secondly, none of the circuits involved should be part of a separately derived system. This prevents any potential conflicts arising from differing grounding references. In summary, the NEC permits the mixing of ground fault circuit, interrupter protected and regular circuits in the same conduit or box, as long as the circuits originate from the same transformer and are not connected to any separately derived systems. This allowance is based on the principle that circuits sharing a common source and grounding reference are less likely to experience voltage differences or grounding issues that could compromise safety or cause equipment malfunctions. Always consult the latest edition of the NEC and consult with a qualified electrical inspector to ensure compliance with all applicable codes and regulations. It is important to understand the technical reasons behind these code requirements to ensure safe and effective electrical installations. For example, consider a scenario where you have several branch circuits running through a building. Some of these circuits are standard 120-volt circuits powering lights and receptacles, while others are 120 volts ground fault circuit interrupter protected circuits serving areas such as bathrooms and kitchens where moisture is present. If all of these circuits are fed from the same main distribution panel and transformer, then according to the NEC, it is permissible to run both the standard and ground fault circuit interrupter protected circuits through the same conduit. This can simplify wiring and reduce the amount of conduit needed, leading to cost savings and a more organized electrical installation. However, if one of the circuits were connected to a generator that provides backup power during outages, then that circuit would be considered part of a separately derived system. In this case, the NEC would prohibit running that circuit in the same conduit as the ground fault circuit interrupter protected circuits, as it could lead to ground fault circuit interrupter tripping issues or other electrical problems. Another factor to consider is the insulation rating of the conductors. As stated in NEC Article 210.8a, all conductors within a raceway, cable, or enclosure must be insulated for the maximum voltage present. This means that if you have both 120 volts and 277 volts circuits in the same conduit, all of the conductors must have an insulation rating of at least 600 volts, which is the standard insulation rating for most building wire. This requirement ensures that the insulation can withstand any potential voltage surges or transients that may occur, preventing insulation breakdown and potential electrical hazards. It is also important to ensure that the conduit is properly sized to accommodate all of the conductors. The NEC specifies the maximum number of conductors that can be installed in a given size of conduit based on the size of the conductors and the fill capacity of the conduit. Overfilling a conduit can lead to overheating of the conductors, which can damage the insulation and increase the risk of electrical fires. Therefore, it is crucial to carefully calculate the conduit fill to ensure that it meets the NEC requirements. In addition to the NEC requirements, it is also important to follow good electrical practices when installing ground fault circuit, interrupter protected and regular circuits in the same conduit. This includes properly grounding all metal boxes and enclosures, using approved wiring methods, and ensuring that all connections are tight and secure. It is also a good idea to label all circuits clearly so that they can be easily identified in the future. This can be especially helpful when troubleshooting electrical problems or performing maintenance. Furthermore, it is essential to understand the function and operation of ground fault circuit interrupters. A ground fault circuit interrupter is a device that detects small imbalances in the current flowing through a circuit. These imbalances can indicate a ground fault, which is a dangerous condition that can cause electrical shock or fire. When a ground fault is detected, the ground fault circuit interrupter quickly trips the circuit, cutting off the flow of electricity and preventing injury or damage. Ground fault circuit interrupters are typically required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. They are an important safety device that can help to protect people from electrical hazards. When installing ground fault circuit interrupters, it is important to follow the manufacturer's instructions carefully. This includes properly wiring the ground fault circuit interrupter and testing it regularly to ensure that it is functioning correctly. It is also important to understand the limitations of ground fault circuit interrupters. They are not designed to protect against overloads or short circuits, and they will not prevent all electrical shocks. However, they can significantly reduce the risk of serious injury or death from electrical shock. In conclusion, the NEC allows ground fault circuit interrupter protected and regular circuits to be installed in the same conduit or box, provided that certain conditions are met. These conditions include ensuring that all circuits are supplied from the same transformer, that none of the circuits are part of a separately derived system, and that all conductors are insulated for the maximum voltage present. It is also important to follow good electrical practices and to understand the function and operation of ground fault circuit interrupters. By following these guidelines, you can ensure that your electrical installations are safe and compliant with the NEC.